This is TM1602 modem, and previously we were using the NAND to read this flash. There are some issues with the reading flash using the NAND device. One is not all the chips are working. There are some chips that does not work, like Toshiba, like this modem. This one has the Toshiba chip, and for some reason the clip does not clip this well. The secondly is the data actually is somewhat encrypted. The real data is using this chip to communicate to the CPU, and the CPU using this data, the protocol using it is using EMMC. So looks to the CPU, it's an external SD card instead of a NAND flash. In this video, we are going to use the EMMC protocol to read the flash, and this way we can ignore the issue with the NAND Toshiba NAND flash. We were not able to do it. Not only that, we can use the Ulink NT to program it. The way I did this is I scrapped the pads here, and I would give the diagram and solder wire, use a pin header here, and hot glue it this way. So the connection to Ulink NT is this one has ground and power. So let's connect the ground and the power, 3.3 volt. The purple is the command line, goes to here, command line. And the clock is using the green. The command 0, I connect the two wires here. So for the Ulink NT, the pin 10 and the pin 8 are connected. So here is how it's connected, and in the software you can click this diagram. Here shows the DAT is connect both to pin 8 and the pin 10, and the clock is go to the pin 6, and the command go to pin 4, ground and 3.3 volt. So now we can do is we can connect the USB. And in the software, we can click detect, and you can see the information about this card. The size of the card is 70600, and the configuration is we have the TM1602 EMMC, and the category using the protocol using the SPI SD card, and the sub-protocol is EMMC. The whole flash size is 7060000, which matches this here. So now let's do a backup. So first detect and then do a backup. So the read speed is about 1 megabyte per second, and the total read time for this is about 2 minutes. This is 128 megabyte SD or NAND flash. And by click here, you can see the data comes in, and they are really readable, and this file can be mounted on the Linux box. So it's a raw SD card format data for Linux to use. I noticed the EMMC method is very reliable. It's better than the NAND read because NAND has some bit errors, ECC, and all those are taken care of by the eMMC controller here. So we talk to the eMMC controller, and eMMC controller talk to the NAND flash. So it takes about 2 minutes, and the whole data is here. And you can see these are much more meaningful than the NAND flash read. So if you go here, you can see they are random response. These are really meaningful. So let's save it and save as call eMMC1. This one, eMMC1. The second feature of this one is erase. And in the case of erase the SD card, this SD card erase will be all zeros. So let's erase it. The eraser will take very, very fast. And let's take a look. We can compare. It will fail, but if I filled eMMC with all zeros, now we can compare the data. It passed. So after erase, the whole SD card has been initialized to 0. So now we can put it back, and let's write it. So the write speed for this device is about 500 kilobyte per second. So it will take about less than 4 minutes, 3.5 minutes probably. The difficult part here is trying to solder the pins here properly. And I find this way is quite reliable. Sometimes, flimsy when you have wires, and sometimes you get it loose. And with the hot glue connected here with the flexible wires, you can get pretty good stable connection. Okay, we finished programming. This is 3 minutes and 20 seconds. Let's verify if the programming is good. Looks like it is. Program success. So this modem uses the NAND flash called MX, which we do have a way to use it using the Unicode NAND. Let's try the other modem that has the Toshiba chip, and we always had issues. So this one has the Toshiba chip, and let's see if we can read this properly and detect. Voila, we do. And now let's read it. We can save it as, let's say, call it Toshiba. And let's unplug. I want to show there is a indication. Let's put software here. Okay, now let's detect one more time and erase it. After erase, it will fail. Let's see. Yeah, everything will be 0. Let's failed eMMC with 0. And they are all zeros. So let's put Toshiba chip back. So when doing the erase, doing the programming, and doing the read, the LED here blinks. So you can see if it's running or not. And also on the lower left side indicate the live writing speed. I'm pretty happy with the EMMC come out because it's not only solve all the issues we had with the previous NAND solution, but also it's significantly faster and more reliable. Because in the NAND case, when we read it, sometimes we get 1 bit error within the sector, and there is no way for us to know the ECC algorithm. But the ECC algorithm is taken care of by this EMMC controller. The Unlink NT currently working with the eMMC is 3.3 volt. If your device is 1.8 volt, you can use the signaling, but you cannot use the power from the 3.3 volt. The signal of 1.8 volt is compatible with the Unlink NT, but not able to directly connect the power from the Unlink NT. So in the future, we might be able to support devices like TV eMMC, but I will collect more board to test. And that eMMC typically is larger than 2 gigabyte, and the current software can only handle less than 2 gigabyte of eMMC. But it's soon, we will have it solved. So let's do a verify for the data we program in. So I will say if the modem or device that has eMMC controller, I find this method is better than the Unlink NAND solution. Not only it's cheaper and less wires because you do not need a dedicated NAND clip. Okay, so we have proved that even with the Toshiba chip, with the Unlink NT eMMC, we are able to program successfully.